Welcome to this webinar, which will introduce Scia Engineer as your solution to structural engineering. More in particular, this webinar will be about concrete buildings. In this webinar, we'll show you how a concrete building is being modeled and calculated. Within 1 hour, the most important steps of the process will be shown. You may read them from your screen. First, the project data is entered, the construction is being modeled, and after selection, nodes will be automatically adjoined where needed. After that, loads are entered and combinations are generated. Special loads, such as wind and snow, may be generated automatically by Scia or applied manually. The structure is then calculated and the mesh will be drawn. Of course, it's possible to change the mesh settings manually. In Scia Engineer 14, there is an option to use automatic mesh refinement, which arguably leads to better results. Then we will make an interpretation of results. We will look at the internal forces and deflections. The construction will be reinforced according to Eurocode 2 standards and regulations. The difference in theoretical and practical reinforcement is shown. The results are made visible in the results viewer. These results are inputted in the engineering report. We will then show you that when the model is altered, the results in the engineering report are automatically updated. So the program you're seeing here is Scia Engineer. In here I will now create a model and you will be able to see which steps I will take to do this. So first I'll start a new project. I'll choose a type analysis. It is also possible to choose certain templates in which certain settings have already been set and certain things have already been done. But I will start with an empty project, so I will choose analysis. And the first step that I'll have to do, I'll have to fill in general data. So first of all, what is the name of the project? So this is a concrete project. Then the description. This is actually for a webinar. The author. Also other general settings like are you working in 2D or 3D? I'm working in 3D. I'm working with concrete. For example, my material will be, let's say the default material will be this one. Default reinforcement will be this material. The code will be the Eurocode. Other choices are available like for example, the IBC or the Brazilian code. But I will stay with the Eurocode, and the national annex that I'll choose will be the Belgian national annex. For the functionality, here you can choose different functionalities to add. I will use subsole in this model. And after I've set these options, I choose OK, and I will start with creating the project. You will see that the main tree is built. The main tree contains options which you just have to run through from top to down. That is the most logic order. You can follow a different order, but this is the most logic one. First of all, we have configured our project data. You can input line grids and stories. You can use the BIM toolbox to convert drawings into a model. This option is used to just create the model. Then you have loads. You're going to perform the calculation and you're going to make a report. Now I'm going to use a line grid in this model. So I'm going to go to line grid and stories. I start with the 3D line grid. And I'm going to say the line grid that I have to use has a distance of 6 meters, which is repeated for 5 times. Same thing for the Y direction. And I'm not going to use the Z direction, which actually means that I'm creating a 2D line grid. So I choose OK, then OK again. Now with the cursor I can select somewhere in the model the point which I want to use for the line grid, or I can also input it in a numerical way. Coordinates are 0, which is the origin, enter. Now the line grid has been placed, and I'm going to go to the structure menu in which I will model the structure. While I'm modeling the structure, I will use the line grid which I've just inserted. You can see it is possible to add 1D members, to add 2D members, after which you might want to add load panels. A load panel will distribute loads to 2D member edges or to 1D members, or a combination. Advanced input is to use blocks or use your own projects as blocks in this model. Then you will have model data like supports, etc. But these model data, they are only available for the kind of structure which you already have. And since I don't have a structure yet, the model data is empty. And you can input some drawings. Again, the normal order is to go from top to down. In my case, I will start with a 2D member. I will start with a plate. And for the plate, you see that the default material is indicated. I will choose a thickness of 300, for example. I click OK. And what I have to do is I have to input the contours of the plate. So for this I can use the line grids. You can see that the points are indicated in a red color. And I can also use, for example, circular arcs or parabolic or Beziers or splines. So we'll use an arc. This is the intermediate point I will use, and this is the end point I will use. And then I just continue with straight lines. This way I've modeled a plate. This is a plain plate. I model it just like this. In the next step I want to add walls. Now for a wall you will have to input the material once again and the thickness, for example 200, and you have the height, for example 3 meters. What you have to do for a wall, actually you have to just select lines, and on these lines the wall will be placed. So for example I will choose this line, like this. But it is also possible to select existing lines. If I use this option, it will become very easy to just select this line of the plate. And this way it becomes very easy to add walls to existing edges. I will also construct some columns. I will use some columns. So for this I'm going to go to 1D member column. For example, circular column will be added with a diameter of 400, which is okay. Choose OK. Choose close. And now I'm going to add a column, and the column is also going to get a height of 3 meters. And I add it into certain points, for example, these points. Just like this. If I want, I can activate the volume model. Then you can see the different volumes. Now for the next level, I'm just going to copy this plate. So I select the bottom plate as one, choose modify copy, and I'm going to copy it from the bottom point to the upper point. In the next step, I want to add openings. So here I have the option opening. And by using this option opening, I can add an opening to this plate. If I double click on opening and I don't know what to do, then I just have to look into the command line. The command line says, for the new opening, please select any slab as master. Okay, so I'm gonna pick this floor. The opening, does it have to be a panel? Like for example, if you have an opening in your roof, but you have a window in it. So no, I'm just going to pick OK. It says what is a start point. I'm going to choose this point, this point, this point. And now I will have an opening into this plate. As you can see here, you have an opening. What I'm also going to do, I'm going to add subregions. So here you can see subregions. And a subregion is a part of a plate which has another thickness and maybe also a different material. Now to work a little bit more easy, I'm going to move my working plane. So UCS move, and I'm going to place it, for example, over here. Next, for the subregion, it's going to ask me select any slab as master. So I'm going to pick this one. The properties of the subregion are going to be, it has this material, it has this thickness. It's gonna have a bigger thickness, for example 300. I'm gonna place it here over this point. So this is actually the point where the column arrives. And I will make a point that is locally more thick, has a local indicated thickness. I'm gonna copy this subregion to the other columns. Actually, for the endpoints of the other columns, I'm gonna copy it to the other points on the plate. Just like this. And I don't know if I've changed this, but the rest of the plate should have a thickness of 200. You can see that I have not changed this, so I can select this plate and indicate that the plate itself has a thickness of 200. Now if you look in the Y direction, you can see that the subregion have a bigger thickness than the plate. Now if this thickness is located at the bottom side, I just have to select subregions. Let's see, this is a 2D member, it's not the correct one. Subregion. And I can select all subregions by using the filter option. I select a certain property and use the filter option. Now I have the 5 subregions together. And I'm going to indicate that the member system plane is at the top, which means that the extra thickness is at the bottom side. If I now look at the Y direction, you can see that it's all aligned. Now if in the next step I want to reuse this level, then I'm just going to copy it. But now I'm going to use a different kind of copy. I'm going to select this part, use modify multicopy, copy it for example 2 times for 3 meters in the Z direction. Now you can see that you've created a bigger building by just copying the bottom floor. For example, in my top floor, I'd like to remove some walls. For example, I pick this wall, I pick the next one, and the next one. Just select them and I remove them. And I can indicate that on this edge, I'm going to add some columns. Now to work more easily, I can isolate a part of the project. I'm going to take this part. I'm going to use my activities to keep just this part. I'm going to add some columns. Now I want to add 4 columns over this edge. To do this, I'm going to go to my snap settings. Points on line must be divided into 4 parts. And the next step, I'm going to add a column. And for the column, I can choose a distance at 1/4, midpoint 3/4. You can also see that it's too long. Now to fix this, I can either redo the option, or I can select the nodes that it has created. For these nodes, I can change the coordinate to, for example, 9 meters. Now the length of the columns has been corrected. For example, this side, I'd like to divide it into 3 parts. It works in the same way. You go to your snap settings, divide it into 3 parts. OK. Add a column. Now I'm going to choose beforehand 3 meters. Pick OK. 1/3, 1/3. And for this last part, I want to keep a big window, so I'm not going to add any columns. I'm going to use beam, and I'm going to add a beam. Let's say it's not a circle, but it's, let's say, a rectangle. I pick a new one, rectangle. Let's add it. For example, a height of 400. Material, for example, stronger material. Pick OK. And then I'm going to add it, and this and this beam is going to have a length of, let's say, 18 meters. It's quite long in the Y direction. So you can add a beam like this to support it. Now we can show my entire model again. As you can see, it's very easy to use these options. And now that I've inputted my 1D and 2D members, I just have to run through the other options. So load panels, I'm not going to use load panels, not going to use advanced input, but I am going to use model data. In the model data, you can see that it's possible to add a surface support or an elastic foundation. This is actually a type of soil. Now you can pick the database, and in the database you can indicate which type of soil that you have. I'm going to copy all the types to my project so I can make my choice in the project. You can see in the project that for each type the stiffnesses have been indicated. So for example, if I have a kind of clean moderate sand, then you can see the corresponding stiffness. Now for numerical reasons, I'm going to insert 0.1 here. And I'm going to add it to the bottom plate by selecting its edge. You see that I actually select the bottom plate and the wall, but it's very easy to find the correct member. It's the S1. So here you have the indication of a subsoil. In the next step, I can add hinges or hinges on 2D member edges, ridges, links. I'm not going to do it. I'm going to continue with connect member nodes. What is connect member nodes going to do? If you have a node that connects to a member, but the member does not have a node in that position, then it's going to automatically connect these two. I'm going to show you an example. Let's say this column. For this column, if I make my model more simple, you can see that this column actually has an end node, and the final node only has a property that is connected to the B18, to beam 18, or to the column. As you can see in the names, it's the name of the column. The node does not know that it has to be connected to the plate. You can solve this by making a new node here, but that would be too much work. That's why we create an option, connect members nodes, and if you execute this option, then the connection will be made between that node and the plate. You see 40 new interactions have been generated. And you can also see that this node has now been connected to the 2D member. For the next step, I'm going to check my structure. So this check checks your model. I'm going to do check. See that there are duplicate nodes, probably due to the commands that I used. I'm going to pick OK, and the project is OK. It's corrected. Now in the next step, I'm going to close the structure menu, and I'm going to go to the load menu. Now for each load, you need a load case. So load. Now each load must be in a certain load case. You can have multiple loads in a load case, but it is necessary to have load cases before you can add loads. Scia Engineer always proposes to create self-weight as a first load case. This means that if you have the load case with property self-weight, then the program will calculate the self-weight automatically. I'm going to create a new load case that has a permanent loads. Now these permanent loads are actually the loads that are added to the self-weight, that are extra loads. And I'm going to create a third one, which is, for example, a variable load. This variable load has to be a variable type, and I also have to indicate the load group, because the load group indicates which type of category the load is. For example, a domestic load. Next step, I'm going to close this window and I'm going to arrive into the load menu. You can see that here you can select the load cases, and under the load case you can see the different loads that can be added into that load case. So to have these options, to have these different load cases, you first have to create the load cases. For example, for my permanent load, I'm going to add a surface load. It's going to have a force of 2.5 kilonewtons in the global coordinate system. And I'm going to add it onto certain elements, certain plates. For example, onto this plate, and this plate. And for example, a smaller load onto the top plate, -1 onto the top plate. It also becomes very clear that the visualization of the load corresponds to the properties of the load. For example, the top load is much smaller than the other ones, because the other ones are 2.5 and the top one is 1. Two and a half, 1. The visualization also takes into account the direction of the load. For example, if I would change the load to the x direction, you would see that the picture also changes. So the picture corresponds to the positioning of the load in reality. For the next load case, my variable loads, I'm going to use another type, a free load. The free load is a very strong feature that allows you to place a load that is not bounded to an element. A free load, for example, let's say we have a variable load of -5. A free load is a load that will project itself onto certain elements. So let's say that I place it over here. This has been added onto what it seems to be the bottom plate. Second plate from bottom. But then if I generate loads, it will place loads automatically onto all plates. Now of course nobody lives on the roof, so I don't have a domestic load onto the roof. So I can indicate that I want to select onto which element the load must be projected. Update to the member selection, and for example I'm going to choose these plates, but not the top ones. In the next step I'll generate the loads, and you can see that now 3 loads are generated. This is a very easy and strong and very flexible option, which allows you to be very free in the modeling of your loads. course, there are also other types of loads. You have thermal loads, you have moment loads, you even have displacements and traffic loads. Now I'm only going to use the loads that I have inputted up to this point. I'm going to continue to the main menu. In the main menu, you see that the next logic step is to create your combinations. For example, I can create a combination, and for my combination I can choose the types envelope, linear or Eurocodes. The Eurocode types will compose the combination according to the rules indicated in the Eurocode. For this type of combination, it was necessary to indicate that the variable load was a kind of domestic load. For the name, I'm going to change the name so that it becomes easy to remember. And this will be the load cases into my combination. So of course I have to add load cases into my combination. I can select one or multiple and choose add, but I also can select add all, and then all loads will be added into this load case. If I pick OK, then you will be able to see that the combination has been made, and it's also possible to check the content of the combination, because the coefficients here are grayed out, because this combination contains multiple possibilities, but by selecting explode to linear, you will see the possibilities inside this combination. So it's possible to take the permanent loads into account as disadvantageous loads, then they get a coefficient of 1.35, or advantageous load, then they get a coefficient of 1. Or with the variable load or not with the variable load. Now I'm going to remove these three, and I'm going to create a new type of combination, for example a quasi-permanent combination. So this kind of combination is used to perform, for example, crack controls. If I want to check the content of this combination, then I can choose explode to linear, and the different possibilities are either just the permanent loads or with the variable load multiplied with 0.3. This 0.3 is a psi coefficient that comes from the Eurocode. The next logic step is to go to the calculation. You can see here calculation in mesh, and I can perform the calculation. Now the other options here are to check the structure again, to check the setup of the solver and the mesh. These are OK for this model, so I'm going to pick calculation and choose OK. Now the calculation will be performed, and it's also possible to immediately check if the calculation is realistic or not. This means you can see that the calculation has a maximal translation of 27 millimeters, which is okay, acceptable. If you would see a deformation of 2 meters, for example, you would know that something is not correct. So by this rough result, the user can have certain insights immediately in the results. For the next step, I'm going to go to the results menu. So in the main menu, you will now have results. These results will allow you to look, for example, to the deformed structure. Here you will see that the biggest deformation comes from my beam over there. It's also possible to immediately look at the beam results. For example, what are my internal forces? Or what are my internal forces for my combination? What are, for example, deformations on beam? Or what are my deformations on beam for my combination? It's also possible to ask for the values, UZ. And for each result that you are checking, you can also ask for the table input. You can also ask for the table results. You do this by using preview, and then the table is composed which corresponds to the results that you see here. So for example, for the deformations, I would have to pick my SLS. I see that I don't have a good name. Then you can see the deformation in each direction, the rotation, but also the resultant of the deformation. This is the total deformation. The same thing can be done for the 2D elements. You can ask for the displacements of nodes. For example, let's say for the combination, quasi-permanent combination, and for all elements. This will give you a colored view of this deformation. You can also look at these internal forces. This will show you in the image what the forces are, the moment lines, for example. So it's also possible to add a 2D member section. Let's say that we're going to add one, I don't know, here. It's actually a bit over this edge, okay. But I can use it to check the results. So again, I'm going to check my internal forces, but this time I'm going to ask him to show it over the section. Then you can see the moment lines in the plate at those positions. Now for the last part, there is also the calculation protocol. The calculation protocol shows you a more detailed results of the total results. So we can see for load case 1, I had a total of 18,000 kilonewtons. For load case 2, I had a 5,000 kilonewtons, and for load case 3, it was around 900. This gives you immediate idea of whether or not your loads were correct. Of course, the program also automatically checks what the total sum of your loads is and what the total sum of the found reaction forces is. This is a very easy check to determine if the numerical calculation was accurate. For the next step, I'm going to close this window, and now I'm going to continue to the concrete window. So in the concrete menu, you can do the concrete calculations and checks. So for example, for the 1D members, first of all, I can show you the internal forces. Now why should I show you the internal forces? Because the internal forces undergo recalculations at this point. Eurocode 2 proposes certain rules which must be taken into account for the calculation of elements. And these moments have to be recalculated by taking into account eccentricities. So the original moment is very small, but the final moment, the recalculated moment, becomes much bigger. Why? Due to eccentricities. We have a recalculated moment for my, because we're asking my. But the same thing happens also for the internal forces on beams. They're also recalculated. Now in the next step, these forces can be used to calculate the amount of reinforcement that is necessary. For example, for my combination A and ULS, I'm going to ask the total required reinforcement, A as total required. And this will give you a representation of the amount of reinforcement which is required. Now for these amounts of reinforcement, of course, it also takes into account certain rules, like for example minimum reinforcement. I can also ask in the preview what the results are. So in the results, you can see that the main upper reinforcement for selected beams is just on one member. There is an upper reinforcement of 5 bars and a lower reinforcement of 3 bars. You can also see that there is a separate table for the columns. Why? Because the reinforcement calculation for a column is different than that for a beam. So for the concrete menu, it's important to indicate what is a column and what is a beam. Now instead of just looking at this theoretical reinforcement, it is also possible to add this reinforcement. Then you would add it as practical reinforcement. For this you can have here the option to input the reinforcement manually or to input it automatically. Now I will perform this automatic option. I will use combination A and ULS. I use it on all values, and now it will calculate the theoretical amount of reinforcement which is required for each element. Then it will take a template and use that template to add that reinforcement into the template. The results are that you can see the reinforcement into all elements. So this way it becomes very easy to add reinforcement into elements by just letting the program do it automatically. In the next step, it is also possible to do certain checks. For example, the crack control. If I want to perform the crack control for, let's say, my beam, I'll pick selection is current type floats combination. I will use the quasi-permanent, which has to be SLS combination. I use A as user. And here the crack control is performed for this beam. The crack control is okay, it's at 80%. If I check into the preview, then the preview will show me very shortly that it's 80%. So now it becomes very interesting to ask for different results. For example, I want to know what the check was for W, for the crack width, and for the minimum reinforcement required by the crack control. I pick these two, reread, And then you can see that the cracks that happened, the cracks that appeared, were not the limiting part. The cracks that appeared are 74% of the maximum allowed crack width. So you can see that W is 0.222 and the allowed was 0.3 millimeters. And if you go a little bit further, you can see that the minimum reinforcement required by the crack control was 311. We provided 603, so it's okay. It is also possible to do a single check, as you can see here. This single check allows you to look at the cross-section in detail. So I choose single check, then it says select a member for single check, select a member. Then you can see the cross-section. And now it is possible for a certain section, which you just have to pick here, for a certain section to look at the loads that were applied, strain, stresses, 3D strains, 3D stresses, forces, and then also of each fiber in the cross-section and also the parts of reinforcement, you can see where the point is located into the stress-strain diagram of this material. The same thing happens, of course, for example, for the capacity check. I've picked selection is all, which means I'm performing this now for all elements. And the result that appears now, I will be able to check if all elements pass the capacity check. Now you can see this in the table, all checks are smaller than 1. So it's good, it's okay. You can also see it in the results here. And it's also, again, possible to perform a single check onto an element. This one, for example. And in this example, you will be able to see the horizontal and vertical section of the interaction diagram. So this diagram is actually your capacity diagram, and your combination of forces must stay inside of this diagram. Of course, the same thing can also be done for the 2D members. I go to 2D member, and here you have member design. For example, if I want to know what the required reinforcement is for, let's say, combination, E and ULS, and I'm going to check the results for the required reinforcement. It's going to be in the 1 minus direction, which means in the X direction at the bottom side. As I've picked refresh, it's going to do this calculation for all plates, which means all plates in the entire model. I just have to wait until it reaches 100%. And now you can see the amount of reinforcement that is required at each position. The same thing can be done for memory design ULS plus SLS. Now what does this option do? This option takes into account both the ultimate limit state and the crack control checks at the same time. So I create a new combination. Let's say this new combination is the ULS plus SLS check. And if I pick refresh now, then it's going to show me what the required reinforcement is for all elements, taking into account both the amount of forces but also the crack controls. So if the cracks at a certain position would become too big, then the amount of reinforcement would be increased so that the crack control would pass. If you want to check a certain plate more into detail, then you can just pick one out of the model. Let's say I pick this one. I'm going to isolate it. And I'm going to ask these results for the current plate. Of course, where it's 0, you don't need any reinforcement according to this check, this calculation. And then from 0 it will immediately jump to something about around 400, because that is the minimum amount of reinforcement which is required. Of course, you can also continue with punching check, but we will not go into detail at this point. Now if you go back to the main menu, the next step is the engineer report. Now this engineer report works actually in a very simple manner. You just have to add elements into the navigator and then the report will be generated. So you add elements here and then you will be able to see the results here. For example, special items, header, footer. So if it's not in the list, then it will not be on the pages. If it is in the list, then it will be on the pages. For example, I can add the watermark. For example, let's say this is webinar. I can add styles, formatted texts, okay, external files. But for example, also sets of data from the project. So for example, the load cases, the combinations, other results. I can also go to the project and transfer results and transfer data. For example, I'm going to go back to Scia, which is now just like a separate program. I will choose, for example, a drawing of the structure. So I will visualize the structure like this, for example, a little bit rotated. And then I'm going to use the right mouse button and I'm going to tell him that this picture should be live into the engineering report. I'm going to insert and close it just with the standard properties. And in the report, you will see here the model. I'm also going to export it as a 3D PDF later on. So I'm going to tick this on. Later on, I will show you this 3D model. You'll be able to see it in a PDF later on. And I'm going to add some other parts. Now what I'm also going to do, I'm going to show a picture with the loads. For example, activate loads for load case 2. I'm going to send this picture also to the engineer report. But first I'm going to deactivate the colors. You can see the loads a bit better. Live picture into engineer report. Insert and close. You will have a new image here. And for the next step, I'm going to add load cases, the table load cases, and I'm going to put the image under the load cases. This way the picture will show the loads for each load case. So to show this, I'm going to regenerate. You can see here in the task menu what the progress is. Then you will see load case 1. There are no loads added manually. Load case 2, you will see the surface loads. Load case 3, you will see the partial loads. So this way it becomes very easy to combine parts, combine things, and show them together. This watermark is not so great. I'm going to make it invisible with this eye option. And then it becomes invisible. Now of course this engineer report is also something dynamic. And you can also add results in it. So results will also be dynamic. So what I can do, for example, I can also go back to Scia and I'm going to make a picture with the results and I'm going to show the results. For example, I want to know the deformation of this plate for each load case. So I'm going to make a selection of this element. I'm going to isolate it. I'm going to show you what the displacement of nodes are. Let's say live picture to engineer report. This image is going to be added into the report. Now back into the engineer report, I'm going to put this image and I'm going to indent it, place it under load cases. Now I'm also going to add some more items. Let's say I have load case 1, image, and then I want to start a new page. I'm going to add a page break, so it's going to show load case 1, image, going to go to a new page, load case 2, image, new page, load case 3, image. Also going to add the page break here. For example, I'm going to add, at the beginning, I'm going to add a table of contents. And then I have this kind of short model. I'm going to regenerate the selected elements. So I'm going to regenerate all those. And what you will see, you have a table of contents, which explains onto which part you have each subsection. Load cases, combinations. My Nelson model went to the next page. I can reduce the heights so that it will fit onto one page. Then I have my load cases. Load case 1 with an image. And also the results of the displacements. Also this is too big in my opinion. Let's pick a scale that is 250. Let's pick also a scale that's 250. I'm going to regenerate this part. And now these images, they fit onto one page. So I have load case 1. I show the loads. I show the nodal displacements of the top plate. I have load case 2. I show the nodal displacements. I have load case 3. I show the nodal displacements. Of course, you have more displacement here because underneath you have those loads. They pull the columns down, of course. Now I'm going to modify my project. And in my project, I find that this column is not necessary. So this member and also this member will say bye-bye. Delete it. OK. Do you really want to delete these entities? Yes, we want. Yes, we do. Now the project has been modified. The strength of the program and the report is that you just have to calculate, because I'm also asking for results, and regenerate it. If you're not asking for results into the engineering report, then you would only have to regenerate the report. That is all. Now I'm going back to my report. I will show you a certain image, for example this one, which I expect will change. I'm going to regenerate all items into the report. So the progress is 88%. It's finished. So first of all, you will see that the element is removed. These elements are removed. We see that the displacement has changed, more displacement here, because the structure has become weaker at that position, more displacement there. And of course not really a lot of change in this module, but you can see that the elements have been removed over there. So if I modify my model, then you will see that immediately. Now for the next step, I will export my project. So here I have the export button, and I will export it to PDF, for example. You'll see that there are also different possibilities. It's also possible to save your list in a navigator as a template to use it again and again later on. I'm going to export it to PDF, for example. So this will be my report. Let's say this is my report 20. And after it's been exported, the PDF will be shown. Here you can see in analysis model that this is a 3D image. You can ask for different views to inspect this element into different views. You can also even go further and activate this option. This allows you to activate or deactivate different parts. For example, I have line sets. I have parts of these columns, which you might see disappearing. Now I'm not really an expert in PDF with this, but I know that this deactivates parts of the image. So this allows you to, even in the PDF, look at certain parts of the picture. Now this was what I wanted to show you into Scia. So to conclude, we would like to thank you for your attention. So I'll give you a short summary of what we have seen. You have now seen how you can create a model from scratch in Scia Engineer, how you can create a structure, how you can add loads, how you can look at the combinations, generate the combinations, how you can perform the calculation to look at the results, and also how to do concrete calculations, like calculations of reinforcements in beams, columns, how to let the program automatically generate the reinforcement, and also how to look at the reinforcement into plates. And at the last point, we also checked how the report could be made and how you can export this to different kinds of output. If you would have more questions, feel free to go to our website and to look around. It's also possible to ask for a trial version so you can discover all these options yourself. Thanks again for your attention, and we hope to see you again at one of our other webinars.